But what we really want to do is to make sure that we get some really healthy dialogue around synergies and opportunities and how we can work together, particularly under the umbrella of the Smartcrete CRC, to create some really good research and innovation that can be embedded into businesses like Sydney Water, where I work, but also other organisations as well. I know that last time, and I believe this time, we've got people from transport and rail, which, while might seem a little bit disparate, actually have very similar challenges that we do. How do we deal with underground assets? How do we get real-time condition monitoring of our assets? So, in our last conversation, we really had, when we were going through the discussion, it felt like we worked from the same organisation. So that really shows that there are some universal challenges that we face across different industries, but we can really approach under the umbrella of Smartcrete CRC and enhance some of how we develop our future cities and where we're headed. So for those who don't know me, my name is Lee Starr. I'm the Manager for Research Innovation here at Sydney Water, and I'll introduce you to Norbert, or I'll get Norbert to introduce himself.
Hi, Norbert Shaper. I'm the Engineering Manager here at Sydney Water.
So I believe the next item on the list, are we going to Michael, or is Norbert going to talk?
Norbert is going to set the scene.
Oh, okay.
Great.
Well, thanks everyone. Thanks, Lee. So I probably just wanted to give a bit of context to Sydney Water, and as an end user of concrete products, what we're really trying to get in terms of solutions for better managing our assets, which will come from, I guess, the R&D that you're doing. So in Sydney Water, we have 25,000 kilometres of buried pipeline, which is our sewer network. The sewers range in size, so they're quite small, 150 to 300 mil diameter, where they connect to our customers' properties. And then they join up and they go downstream. They progressively get bigger until they reach one of our 30 treatment plants. And by that stage, they're quite large. We have some sewers that are over 2 metres in diameter. We have concrete culverts with sewers that are concrete culverts 2 metres by 3 metres wide. Large critical assets. At the moment, the most cost-effective way of us managing the majority of that network is to wait for it to fail and to go out and fix it. So we've got a large number of crews, a large number of logistics to prevent those environmental spills occurring. But then we have, I guess, a couple of thousand kilometres, which is so large that failures are just unacceptable. The consequences we can't manage. And we need to internally inspect those sewers regularly so that we can repair them just in time. We monitor the degradation. And of those couple thousand kilometres, we have a few hundred, well, actually more than 1,000 kilometres of sewers that are so large that our remote sensing, our non-man entry solutions for condition assessment just don't work. So we've actually have a hazardous program of person entry sewer inspections so that we can monitor the deterioration and repair them just in time. So in terms of, I guess, a business managing those assets, we really need the capability to be able to monitor the deterioration of those sewers cost effectively in order to plan the rehabilitations that are required. We need to reduce those hazardous person entry inspections. So currently 650 kilometres a year of where we're doing person entry inspections. And when I mentioned that it's most cost effective to for the majority of our sewer to have it fail and then have a huge logistics operation to get out there and manage the failure, it'd be great if we had the technology to actually increase the proportion of the sewers that just don't fail, that we're managing proactively. So for managing our current fleet of sewers, some of the work that's being started around photonics is really one of those first steps in being able to better manage our sewers. Over the next 20 years, Sydney's going to be growing, so we're going to also be putting in new sewers, new treatment plants, new concrete. So again, in terms of having concrete with a smaller carbon footprint, more sustainable, more into circular economy, we'll get more durable concretes, self-healing concretes. They're all, again, would be fantastic for us to have for our new assets, but that won't, I guess I consider a lot about our existing assets, and I don't want to lose sight of those, that 25,000 kilometres of buried pipe, and we'd like a way of being able to manage that more effectively as well. That was I might just leave it there. That was the main thing I wanted to say.
So Norman, I guess there's, like, if you think about our whole organisation, we've got that existing assets which are ageing.
Yep.
Not only within Sydney Water, but other water utilities across Australia. So we need that real time. How do we manage that in a way that what smart technology or what sort of technology can we use to understand when that's going to fail, predict that predictive, and rather than the reactive maintenance is actually a lot cheaper for our organisation.
Yes.
So we're dealing with a really old kind of network. But then I guess the exciting thing is when we move into this Western Sydney development and this new space, we can actually we've got this opportunity right now, not just Sydney Water, but other water utilities and even other utilities where we can use or leverage off Smartcrete, CRC, and identify ways of actually, well, what's that future look like? How can we embed new technologies or new ways of doing as we roll out these new parts of our cities and new parts of our networks, and how might we be able to, I guess, collaborate or leverage, not just through the water utilities, but the energy or through rail or even roads and transport would be a really good opportunity there in terms of that smart concrete or smart ways of doing things. So, Michael, you've done some work with Sydney Water for many years, I acknowledge, for many years, and there's been a couple of projects that you've done with us recently under the umbrella of Smartcrete CRC. Can you, share with everyone within this community of practice about what you've done, how you've approached it, what the benefits have been, and where you actually see the future going in this space?
Sure. I've prepared a few slides, Lee, if you will indulge me. So
great. We can do that.
Okay. So.
And if anyone has any questions, just pop them in the chat. There'll be time at the end. If you've got comments or questions or, ideas, it'd be great that's where we kind of get where the rubber hits the ground, where we can actually see how the community can work together and identify ways and synergies moving forward. So I'll pass over to you, Mick.
Right. Can you see my screen?
No, I can see you.
Okay, let's try that again then.
Okay, it's loading up now. Yep, good to go.
Fortunately, it's loaded up the wrong one. Just bear with me.
It does say May 24. Another community of practice. You're
It's okay. It's an early version, but let's go with this. In the interest of time. How do I get full screen on this?
It's not too bad from this end.
yeah, it's good view from here, Mick.
All right, let's just move forward then. All right. Yeah, so as Lee said, we've been working with Sydney Water and Melbourne Water for probably 7-8 years now. And the original brief that Sydney Water at the time came to us with was to try and actually develop long-lived sensors, particularly relative humidity sensors that would survive in the harsh conditions that is a wastewater environment. That actually flowed into try and develop techniques that could actually measure in situ the corrosion rate of the concrete itself. And a most recent project we've had with Sydney Water and Melbourne Water is actually then try and reduce the cost of the entire package. So I've got a few slides. I don't want to actually dwell on the technology behind the sensors themselves. I more want to actually reflect on our approach to try and address the industry brief and actually deliver on those deliverables. So as sort of Norbert alluded to, wastewater pipes can be quite hostile. They do suffer corrosion. There's a lot of volatile gases in there. I'm going to start off with the water vapor. That's the starting point. So they're highly humid environments. Now there are on the you can actually buy relative humidity sensors off the internet, or there's many companies will supply them. Those of you watching this presentation in an office building, you probably have relative humidity sensors in the roof space above you. But most of those relative humidity sensors are actually only specified up to 90% relative humidity. It's actually quite hard to find a relative humidity sensor that can actually that is rated for above 90%. And as you sort of see there in the dot points, what the wastewater conditions are usually well above 90%. And indeed, I've come across some recent research that suggests that the chemistry that actually feeds into the corrosion process actually changes a lot between 95% and 100%. So it's quite critical that we actually find sensors that are very sensitive and accurate in that particular range. There's other gases as well. There's hydrogen sulfide, which I'll get back to in a second. There's also sometimes high methane conditions, so there's a risk of explosion. So that you have to bear that in mind when you're considering a sensor solution to address this particular problem. And it's highly corrosive. So there's a biofilm that forms not just on the concrete itself, but potentially on your sensors. The biofilm actually converts the hydrogen sulfide into sulfuric acid, and it's the sulfuric acid that actually eats away the concrete. And that's what we're actually trying to address and indeed measure, both with the somewhere measuring corrosion rates, but also looking at the precursors that actually feed into those corrosion processes. And the other consideration for a sensor solution in this space is ideally it has to be remotely accessible, because you don't want to have to send people down there and actually read the individual sensors themselves. So as it is hard actually to find relative humidity sensors commercially available that actually address that sort of space between 90 and 100%. This is one I found. So it's an electronic capacitance-based sensor. I've got short-lived and hostile environments question mark. So if you look at the advertising notation for a lot of these sensors, they do claim they can actually survive hostile environments. But certainly the anecdotal information that we've had initially from Sydney Water and Melbourne Water, that's since been endorsed by other water utilities, is that the sensors typically only last a few days, weeks, maybe a month at most in these this combined this environment where you've got both high humidity and high H2S. And indeed, as you can see there, even high humidity conditions, the accuracy of this particular sensor doesn't really fit. It's not really fit for purpose in that 95 to 100% range, where its accuracy is best plus or minus 5%. that's not really going to help unlock some of the sort of subtle chemistry that that recent research paper that I alluded to is reflecting on. So our original approach was, again, not to reinvent the wheel. We did an extensive literature review to see what sort of other alternate sensor approaches were out there. We found a few papers that were actually referring to the use of optical fiber sensors in wastewater environments. So optical fiber sensor is, in essence, just a strain sensor. In this case, so if you have a hydroscopic coating around the optical fiber or around the strain sensor in the optical fiber, the hydroscopic coating will actually expand and contract relative to the local humidity, and that actually induces a strain on the fiber, which we directly measure. So we looked at the literature. We decided we could probably do a little bit better than what was reported in those papers, and that sort of was really the kickoff point for our engagement with Sydney Water and Melbourne Water 7 years ago. So what's shown there on the right-hand side is actually one of our sensors. We actually write the strain sensor with our manufacturing techniques directly into the fibre itself, and we use 3D printing to make robust packages that sort of survive the hostile conditions of wastewater pipe, including biofilm formation, that sort of thing as well. Our accuracy at 1.5 plus or minus 1.5 is superior to the commercially available sensors. Ours are remotely accessible as well. I'll show you some examples later on where there's we're reading the sensors from hundreds of meters away. So we go back to a control room or base station of some sort. And what I haven't said that is they can also be multiplex. So you can actually have multiple sensors on the one line, as opposed to electronic sensors, where every single electronic sensor has to have its own copper wire. And so if you're talking about hundreds of sensors, and you're talking about a big bundle of copper wire feeding into those. So does it work? Well, I'm pleased to say that we met our brief of a long-lived relative humidity sensor. The sensors also give temperature. So what's shown there on the right-hand side there is the red is the relative humidity sensor data over 6 months of testing at Sydney Water's North Head treatment tanks. That's two of my team members shown there during the installation process. The blue curve is temperature. That's about a 6-month time frame. But that same sensor has been operating out there continuously for 4 years now, without failure, without having to be recalibrated on a regular basis. We do go out there and do spot calibration checks from time to time, just as part of our due diligence. So it works, deliverable met, which gets me to the second deliverable that we're tasked with at the time. And that was actually coming up with some way of measuring in situ fashion the corrosion rate. So we actually did a range of extensive studies leading up to this point, including 3D tomography using ANSTO's neutron beam tomography beamline, where we actually looked at some core samples that Sydney Water provided. We improved on our understanding what the corrosion front does as it actually progresses through the concrete block. We did chemical testing and analysis as well, so we can actually identify the formation of ettringite and gypsum. The 3D tomography sort of showed strain and decracking events associated with that corrosion front. So we decided, well, one thing we could actually potentially measure is actually that the strain associated with the corrosion front. And that's exactly what this sort of little schematic on the left-hand side is showing, where we have 10 sensors at different depths from the surface of the left-hand surface of the concrete block in this case. And they're there to actually measure the strain associated with corrosion front moving from left to right in that particular block. The other thing we did that we learned from the 3D tomography, because we actually went out there and repeated some of those experiments, but with sensors in concrete this time. And we did dynamic studies to watch how the corrosion front, or in this case a water front, would actually interact with the sensor. Because we're always sort of forward thinking, trying to think, okay, what's the handover process look like to Sydney Water and Melbourne Water? How do we actually train their technicians in actually installing these sensors? Now, originally at the time, we'll imagine drilling into the walls of the concrete pipe, installing some of our little sensors. But what the 3D tomography showed was a waterfront would actually wick around the drill hole and the installation point for the sensor and not interact with the sensor at all. So we had to sort of throw that out as a potential approach for deployment, and so we went through a different approach, which we now call the Spark Coupon, where we actually have a piece of concrete cylinder. It actually has sensors embedded in it, as shown on the left-hand side there, and that serves as sort of a canary in the coal mine. It measures the corrosion rate in a relative fashion and can actually infer what's happening in the actual concrete pipe structure that it neighbours. A little cartoon on the right-hand side there sort of just shows you how the concept works. So as the corrosion front moves past each of those sensors at different depths in the concrete block, we register an event, and we can actually track the corrosion front as it goes through several sensors over a period of time and actually get a corrosion rate. And that corrosion rate can then help us predict when we're going to reach the failure point of a particular concrete pipe that's in that area. And the failure point in this case, going back to the Norbert's introduction, would be where the rebar is actually exposed, and Sydney Water then have to go and rehabilitate at great cost. So this is the final embodiment of the sensors themselves. We're currently field testing or field validating these, again, at Sydney Water's North Head treatment tanks. It's a great test site because it's one of the areas where the H2S levels are very, very high, and high humidity as well. So this is where corrosion is at its worst. And so we're actually seeing corrosion vents. These coupons have been out there for well over 6 months now, and we're actually starting to see some of that initial onset of corrosion with those sensors very close to the surface, and already getting a sense that in this particular harsh environment, our canary in the coal mine is registering a vent of or corrosion rates of about 0.5 millimetre per month. Now this is extreme case. Sydney Water's normal networks will never see rates of this high. Typically, there will be a few millimetres per year. I've heard up to 5 millimetres, sometimes more. Which, going to Norbert's point, they want 100 years lifespan out of their pipes. If you're corroding it over 5 millimetres a year, that means you probably only get 20 years out of a particular pipe before you have to rehabilitate it. The goal that they've expressed to us many times is to get those corrosion rates down to 1 millimetre a year, if not lower. And that's where sort of measurement protocols of this type, we hope will help them get there, help them with their sort of mitigation protocols to drop those rates. And so finally, the third brief we had was actually drop the costs. So when I showed you the image of our guys actually installing it at North Head, the original long-lived humidity sensor, the box on the left-hand side there was what they were actually installing in the control room out of that site, and then that actually interacted with the sensors with about 100 metres away in that case. The little black unit inside of that control panel is quite expensive. They're a commercial optical electronic data acquisition component. They're worth many tens of thousands of dollars. One of the reasons they're worth tens of thousands of dollars is because they have high sampling rates, because these are devices made for other sensing applications, where often you need kilohertz sampling rates. We don't need high sampling rates for this particular application. Indeed, hertz level is fine, or even less. A few data points a day in some situations are going to be fit for purpose for Sydney Water and Melbourne Water. So to try and actually reduce the cost, we've been building a low sampling rate replacement of those commercial units, and it's sort of shown in the blue box on the right-hand side there. We've got a target price for that for about $5,000. So it's about 1/10 of the cost of the commercial systems. And so this is sort of, again, part of our effort to drive down the costs and get to a price point where Sydney Water can actually start to actually adopt and deploy at scale some of these units. I'll stop there. So the sort of take-home messages I want to land on was, we try to avoid reinventing the wheel by looking in the literature and just trying to do better than what's already out there. If we do have to actually, if it is a sort of greenfield application, then we try and make sure what we're doing is fit for purpose, so we don't over-engineer it. I think this has been quite a effective and productive relationship with Sydney Water and Melbourne Water over a long time, largely because we have effective communication with our industry partners, and by effective I mean regular cadence of meetings, and indeed every meeting is actually minuted, so everybody knows what the expectations are for the next period of time. And I guess, and then finally, keep an eye on the end goal, which is at some point there has to be a handover. You need to actually engage in some sort of training process with industry partners, a handover, where they're not reliant on PhD students or postdocs having to be part of the installation process. The solution has to be fit for purpose, where a skilled technician can actually deploy these in a reproducible fashion. So they are open for questions, and thank you for your time.
Thank you. Before we jump into questions, I just wanted to make a comment, and which is, Sydney Water really values our research partnerships that we have. We have a Sydney Water Research Network, but we also participate in things like the Smartcrete CRC. And like Mick, who does his desktop studies to see what's available, we do our scans as well. We'll scan and see what's available. And if there's something is not fit for purpose or doesn't, fit or can't address our complete business challenge, that's where we lean in on these types of partnerships to kind of help us solve those problems and create fit for purpose pieces of technologies and materials. And we just to reiterate, we really value these relationships. They really drive innovation within our organisation. I think the hardest thing for us is probably the deployment and getting through the procurement. We've done all this space and we're working on that internally. But how do we we've tested it, we've proved it. Okay, now how do we roll it out? So that's, a challenge for our organisation, who really has a low risk appetite, even though we run our assets to fail. It's confusing. It's confusing. Anyway, I just want to put it out there. And does anyone have any questions for Mick around the technology that he's done, or, how it might relate to your organisation, or ideas of how it could be transferred into different areas? Brian. Sorry, Brian, I can't. I've got new glasses. I can't read and I can't see, so it's all very confusing. Brian.
G'day, Lee. Michael, I'm just interested in the corrosion sampling technique that you've developed. Is anyone using that approach when they're designing new durable concrete and doing that testing in situ well in advance before someone wants to specify construction? So, where you have a very hostile environment for concrete, you can come up with new plans and actually put that in the environment and just see how that concrete performs long before you actually even specify it.
Look, not that I know of, Brian, and indeed, we took a long time to actually land on a concrete formulation that we thought would both represent some of the sort of standard formulations that Sydney Water have in their pipe networks, but I would ideally corrode a somewhat faster rate. So you get some sort of data in a short period of time, as opposed to having to wait years for an event to happen. So, and that's under highly corrosive conditions. My fear is maybe the sort of situations you're referring to, Brian. You may be waiting many years for to get the register the first corrosion event, but it's not impossible. Somewhat related to that, one of the reasons we landed on this particular smart coupon concept was on the back of some of the studies we did looking at concrete curing. So the same strain sensors can actually tell you a lot of information about the nature of the concrete curing process, which may inform people such as yourselves about whether the concrete is actually cured to its sort of right performance, strength, things of that type. So yeah, we see a lot. We see sort of expansion and contraction right through that curing process, and that in itself may be informative.
Thank you.
Does anyone else have any questions for Mick? Okay. Does anyone have any questions or comments for Norbert about what he presented earlier? Or comments? So as a community of practice, it's, you know, a really good opportunity maybe to talk about the challenges that you have and see where the intersections are. And I know that there is funding available through Smart Creek CRC. There could be opportunities for this community of practice to actually develop something that addresses challenges across different industry partners. So if you've got any ideas, you know, this is probably a really good platform to discuss those. I'll just hand it to the floor and see if there's anyone there who might be willing to put something forward, or ideas or comments.
Or maybe while we're waiting, I've got a follow-up comment for Brian. We're engaged in yet another study looking at marine wall corrosion, and indeed we believe we can actually differentiate saltwater front moving through concrete towards a rebar as well, and distinguish that from just a pure water front. So again, I think that goes to some, you know, the essence of your question. But I see Zoe has a question.
Sorry, just before you go, Zoe, I wonder whether there's an opportunity for seawater ingress in some of our speaking to that. What you just said, Mick, building on that, is we've got a lot of pipes that go into the
travel
ocean.
under the water table.
Yeah.
And we can use our flow monitoring and even our pumping stations to see that the flow goes up and down with the tide.
Right.
So then, and we have tried salinity monitoring of the actual wastewater, but it wasn't a bit like your humidity sensors. We couldn't really get enough accuracy at the right level to determine exactly where it is. And then our other challenge is if there's large point sources of inflow, they're easy to repair. But if it's distributed, if there's fine cracks along kilometres, the cost of relining that whole sewer. So that's I guess the challenges we have in terms of ingress. Yeah.
Food for thought.
Food for thought. Put a little pin in that
Yeah.
one. Zoe.
Yes, thanks.
Would you mind just introducing yourself so
Yeah.
people know where you're from?
Can do. Sorry, just looking for my camera as well. Yes, I'm Zoe Schmidt. I'm from Adbri. Adbri are material suppliers going from cement, concrete, aggregates, etc. Just touching on what Mick said a short while ago about being able to use sensors for curing, that has far-reaching possibilities, Mick, even outside of what we're talking about today. So that sounds really exciting. But my question really relates to the concrete specification specifically, which is fairly prescriptive. And I think it's the, if I've got the right version or the most recent version, the technical specification for Sydney Water, version 10, I believe, which obviously prescribes minimum cementitious contents, maximum water cement ratio, slumps, etc., which makes a lot of sense. There's also some more recent work that's been done around the embodied greenhouse gases measured as kilograms CO2 equivalent, which is based on calculations which are quite simple and effective, I suppose, because they're just looking at cement and the appropriate supplementary cementitious materials and their values. There's a lot more EPDs available on the market now that actually will be able to give you that data right down to every material that goes into it. But I note that the parameters or the measurements used to be able to derive that number, for cement and fly ash and what have you is a little bit outdated. Things have changed a little bit. So I'm wondering how we can engage with Sydney Water to maybe talk about more recent numbers that are available and how we can optimize that, and how we can maybe talk about alternatives that might actually bring down the total embodied carbon of the concrete of a given mix. How do we do that?
Yeah, so you can reach directly to me, Zoe. I can put my details in the chat before the end of this meeting, and yeah, start with me. I manage the team that looks after our civil spec, and we're always open to suggestions and improvements. So that'd be great. Thank you.
I will reach out to you. Thank you.
And there's also like just on that, and I guess this is why this sort of platform is really valuable, is because you can start with that, but then there's also the carbon net zero team that are looking for ways of reducing our net carbon zero like improving our targets.
Yes.
So there's a real synergy across our business. Our business is very large, and lots of things happen right across the business, but it is really good to do that collaboration internally as well.
Because it is interesting. Our internal sustainability team sent us some research that had been done on concrete with, I guess, what those latest targets were, and we were sort of quite pleased that they were pretty much in line with the targets we had in our spec. But if there's better ways of doing it and other intelligence that's around, we'd be open to that. Yeah. So.
Oh, fantastic.
And I just wonder how they meet. Like, have they got standards behind them?
Yeah, they have, I think, and just looking at the data itself, there's obviously decades worth of work that's been done on the durability of concrete, and it's quite easy, I suppose, to actually draw on historical data. But I think there's also a lot of new stuff coming up that might be of interest, and that's where maybe the research component of it comes in potentially. But also how relevant is that historical data now in line with what we're doing, which is really working with materials that are more sustainability focused, I suppose.
Yeah. There is a real challenge here. I think concrete specs have evolved very slowly, quite conservative, and there is that. We talk about very long-lived assets and how much evidence do you need before you make a change. But yeah, I guess having that discussion's a good way of understanding, particularly if you've got information that we haven't had available to us or been aware of.
Oh, I think it's just a matter of that we're working in that space all the time. So probably, and it is evolving rapidly. So, but there's an opportunities to take advantage of some low-hanging fruit. That's easy. But then, of course, there's the more difficult ones. You know, that what you're relating to is how do we harness some of the new technologies available, and how do we ensure that there's at least that level of durability and longevity that goes with those new materials.
Yeah, you definitely need that confidence, particularly within Sydney Water. And I'm not sure, is there anyone here from Roads and Transport?
Harish is, and he's just...
and he has his hand up.
I just sort of tried to chime in.
Yes.
I think it's a like ever-going discussion about chicken and egg type of a story, because as an asset owner, we require assurance around 100-year design life. And lot of new materials, they don't have track record to prove that. Only means of proving is accelerated testing, which also answers part of Mick's presentation where he was sort of saying, and probably Brian also raised a similar sort of concern. And I guess that's probably one of the things. This is still unknown. There is no written standard how much accelerated testing is good enough. So everybody is taking a punt and coming up with some model, and that's where basically this discussion starts and probably stops, and these new materials don't go anywhere, because it's again sort of comes down to who takes that risk. And because the way construction contracts are structured, you have defect liability period of 1 year and structural warranty of 7 years. And after that, 93 years is asset owner who have to sort of take carriage of it. So I think that is the sort of one biggest risk probably nobody is trying to address. And that's where this response to this innovation lies, how it can be embraced more quickly. I think this is the story with geopolymer or anything you take, it's just that's the story. So I think, and the other problem which I think with the performance specification is it's sort of pretty much it sort of is performance specification in favor of the big suppliers, because they have got reach to all the testing and everything so they can support their sort of product with lots of testing, whereas the small suppliers, they will lack that. So that will be the another, particularly from the procurement space, when you and I go and have the discussion with procurement, they will sort of say, you are trying to kill half the competition. And probably that's the sort of another probably impediment to this. And probably nobody has got a ready-made answer to it. It's all risk-based approach and probably a lot of consultation, internal and external required. But I think to me, these two things, if we can solve, probably we can very liberally adopt any innovation.
So what you're saying is to get that confidence that those assets are going to live, the new assets or the new types of assets that are coming through are going to last long enough that you have the confidence that it's not going to provide a risk, but also that procurement are on board. And this is not a the challenge around procurement came up quite a lot in our last session. It is something that needs to be addressed. I'm not sure whether Smartcrete CRC is the right avenue for that, but it definitely needs to be addressed.
Yeah. There is another working group, MECLA. I'm not even quite sure what that stands for.
Yeah, I'm part of it.
Yeah, you are, yeah. Harish, yes. Yeah. The other thing, I see an opportunity, and it might not just be within Sydney Water, but with the growth of Western Sydney, where we've got a lot of really big, high-profile projects that are large enough to have sustainability measures. And often on small jobs, it's really, you don't have that that momentum, that sort of size of investment to be able to put in a reasonable percentage to pursue sustainability goals. But I think some of our bigger projects out of Western Sydney have those sort of goals in place, and we can build in right at the beginning of project specification that we're going to trial some of these green concretes in non-structural applications where we can actually have monitoring, and typically they get discounted during the procurement stage because they're more expensive. But if we actually set up projects with those goals in mind, build in the opportunity and the trials right at the beginning of projects, that way we'll start building up more, I guess, real world data.
I think one of the biggest challenge with the trials, which I have seen, is like we do not have success criteria attached to it. And I guess that's where we lay a piece of concrete and then forget about it.
Yeah.
So obviously we don't get to know what happened to that concrete because it's laid as part of the project as a trial, and there's no budget or no maintenance or no follow-up of that concrete. So I think that's where we do not have any data. It's not that doesn't mean that we have never trialed anything. Hundreds of things have been trialed, but we don't have anything in the database. So I guess that's where things like what sort of Mick is doing with the sensors and things like that, because they create a database. And I guess you can go and interrogate it and sort of say, instead of looking for a piece of paper, you can see in a graph how this 6 month is performed. And I guess, but again, that sort of comes if you have got only short-term objective, 3 years, 2 years, 1 year, it doesn't go. It's some sort of sensors which should sort of have real enough life to, without reinstalling the sensors, you can sort of get a tangible data which can be used for calibrating some of these prediction models. And I guess probably it needs to bring in likes of a Standard Australia, where you have got some guidance, because all of the Sydney Water Transport for New South Wales, we all engage external consultants. They lean on the standard to protect their sort of liabilities. And I guess if these guidance don't get built up into the standards, whether it's like a simple guidance, you do that many cycles of accelerated testing to sort of rely on the result for forecasting the life. And I think these things are missing links, which probably that's where we all sort of talk and think very progressively, but when it comes to sort of adopt it, we all get sort of shackled by these things. So
yeah, they're definitely universal challenges across industries and utilities. I agree. And I have not worked in this space for very long. I've only been at Sydney Water for just over 2 years, but these are the conversations, they're similar conversations coming through. So for me personally, in my old world, it's those conversations that keep coming up over and over again are where the opportunities lie, and that's where you should be focusing on, because yes, they're challenging, they're complex, otherwise they would have been solved already, but that is where you create real innovation, because you've created that step change in how something that's been a problem for a really long time. If we all focus on that, that's how you progress innovation, and that's how you drive change. So there's a real opportunity there. Does anyone else have any comments or identified, synergies or opportunities, or facing the similar challenges? Mick, do you have any comments based on some of the things that have come through?
I just something Harish said sort of reminded me that one of our reasons for directing our attention towards optical fibre sensors is we're trying to leverage what the telecommunication industry expects the lifetime of their components to look like. So optical fibre has been designed and specified the last 50 years in the ground. So we're trying to actually capitalise on those sort of long lifespans and actually translate those to some of the needs in asset management. So perhaps I can't guarantee 100 years out of one of our sensors, but certainly we believe they should be able to last decades based on all the large investment the telecommunications industry has gone on, has done behind the scenes to make the fibres as their current.
Come on, Mick, you have to innovate.
Faster, Mick, faster.
Corning and some of those multinationals have spent billions of dollars actually getting the fibres to where they are now.
Just link into them. One thing that did occur to me is that we do lots of IoT, we do lots of different types of sensors across the organisation, and the challenge we have there is the short lifespan of that. And I know, Mick, we've been working with you to try and reduce the cost of what you've been producing. But I'm wondering whether there is there's and this is something that would be kind of taken internal, but maybe the cost benefit of, that replacement, that continuous replacement actually the cost of your product or the technology where it is now. Maybe that's the value. The value proposition is that that's long lasting and you don't need to replace it over time. Maybe that's one way that we can communicate internally of how it creates value for the business. Yeah, just a thought. No promises, but just, you know, how can we think differently about upfront costs versus long-term maintenance and condition monitoring and things like that.
Yeah, and I think particularly about scaling up, how we can reduce costs and make sure that the systems that we start with, that might be a couple of hundred, can grow to a system that's tens of thousands.
Sure.
And I guess even like when you think about, I'm going off topic here, but smart meters, if we were to put smart meters in every household in Sydney, it would take about 10 years. Like by the time we get to that last house, like the world is going to be a different place. So how do we keep pace with that while rolling out these sorts of technologies? And how do we do it in a really efficient and useful way for each, you know, the different type of network, whether it's new or whether it's an old network. Sean, did you want to make any comments? Yes, because you turned your camera on. But you're on mute.
Yeah, thank you very much, Lee. Yeah. So I'm not sure whether I missed it. Oh, by the way, my name is Son. I'm from, well, I have two hats. One is with Smart Grid CRC. So today I'm actually here, you know, from Smart Grid CRC. So that's why I don't want to say too much about research, you know, potential collaboration or work here, but obviously I got a lot of ideas and, you know, all the needs from the industry, and then maybe I will contact some of you if, you know, it's okay by email. So just about what Mick has presented about the corrosion monitoring. So I just wanted to make sure that I understand. You may have explained to us, Mick, but so when we say about corrosion, generally, because I'm a structural engineer, so I'm looking at these steel bars inside, you know, concrete structures. So with your technology, with your optic fiber sensors, so you have to put those sensors, you know, at the bar surface, isn't it? Nah? And then, but obviously, I think we discussed this before as well. So we don't really know when it's going to happen, isn't it? And whether we can really detect exactly when it started to happen as well. So and then with the this water utilities, the pipe that you've been working on. So are you measuring what you call the corrosion or the crack or the movement? And then how is it applied to that steel bar corrosion? Because I'm developing a new proposal looking into that, but we'll use more like the ingress and also the cracking from the surface, and how we can predict the corrosion rate of steel bar. So I'm not sure whether your sensor technology will be able to, you know, work in that space and maybe correlate with AI technology to predict the corrosion rate of steel bars inside concrete structures.
So firstly, and then maybe Norbert and Lee can correct me, once the corrosion front gets to the rebar, their rehabilitation costs, I think, jump fourfold, or yes, it's quite a. So the idea is actually getting their rehabilitate before it gets to the rebar. As I alluded to before, the 3D real-time tomography we did out at ANSTO sort of told us that retrofitting sensors into existing concrete walls was problematic, probably never reproducible, fraught with a lot of issues. So this is why we decided we had to land on a standard, and this is, again, in consultation with Sydney Water, a standard that could actually be hung easily in the airspace next to a concrete wall of interest to Sydney Water. And the idea is actually to, with digital twin sort of modelling, is to identify hotspots where the corrosion rates are actually running at a rate that's much higher than other areas, and that way Sydney Water can actually use some of their mitigation protocols to actually try and bring that corrosion rate back down again. The other problem is, you know, that's for argument's sake to say there's 150 mils between the existing or the original service and the rebar. But that's some of these concrete structures are, you know, 50 years old, so you don't know how much concrete's been lost and how much concrete's left there. So there's always some uncertainty with respect to that predictive capability. But the idea is, you know, if you think you've got 100 mils there and you're running at, we're measuring a millimetre corrosion a year, then you got predictions tell you you've got a 10 years lifespan. Well, let's say 9 years before it gets to rebar, and you have to get in there and rehabilitate. So that's the kind of concept. But again, it was all about having some sort of controlled, scalable deployment measure that could give them relative corrosion rates, because giving an absolute corrosion rate in the existing concrete walls was too problematic.
Thank you.
Thank you. I'm just keeping an eye on the time. It's probably time to wrap up, unless anyone has any last quick question. I'd like to say a big thank you to Norbert. I know you're really busy. Thank you for making the time to come and talk to the community of practice. I'd like to say thank you to Mick. You know, your collaboration and partnership and research is always valued by Sydney Water, and as is your time. And thank you to Jana for organising this and really providing a platform for people to talk about how we might collaborate with asset management, and by showcasing some of the things we've already done, but, you know, where we might be going into the future. So my plant a little seed around, we've got a tale of two cities in Sydney at the moment. One is ageing infrastructure, and one is what technology can we put into the new infrastructure that's been rolled out, and how do we manage our assets for that future. So enjoy the rest of your day, and we hope to see you at the next Community of Practice. Thank you.
Bye.